Welcome back to Ratio Fitness. Today's ratio is the glucagon to insulin ratio, or GIR. This is about two opposing hormones, or what they refer to it as a bihormonal ratio, which varies in the presence or the need for catabolism or anabolism. And what are we looking for? Catabolism of what? Body fat. Yes, that's why we're here. So, glucagon gets excreted out of a pancreatic alpha cell. So your pancreas has alpha cells and beta cells. It also has gamma cells, but that's another day, another topic. So the pancreatic alpha cells have what's called a GLUT1 sensor. Now the GLUT1 sensor, I refer to it as a lazy Pac-Man. It's sampling glucose pellets every once in a while. So remember the video game Pac-Man where it goes wonka wonka wonka. So this GLUT1 is opening its mouth and sampling, if you will, or opening its pathway and sampling glucose. But when the glucose is low, what happens is not much glucose comes in, not much ATP gets made from the mitochondria, which causes this potassium channel to open, hyperpolarization occurs, and this calcium channel allows a bunch of calcium into the cell, which interacts with the vesicles, which results in glucagon exocytosis. Now, kind of similar but different is the insulin that comes from the pancreatic beta cells. Again, lots of glucose gets in, the GLUT2. Now, the GLUT2 is like a security guard managing the doors on Boxing Day at Best Buy. It's a silly example, but you'll get what I mean. You know, on Boxing Day, when there's 8 million people out front, so what you have here is all these people out front waiting, and then they get let in. Glycolysis, mitochondria, increased APT. The increased ATP closes the potassium channel, depolarizes, so kind of the opposite here, depolarizes, and then again, the depolarization causes calcium to flood in, deals with the vesicles, and we get insulin. So similar, but different. Do you see what I mean there? Anyway, that's this topic for today. Thank you.